Our third panel of the day is Maturing a Data-Centric Army. Data is everywhere, with growing numbers of sources, types, and users, not to mention the large language models and AI. This next panel is going to discuss how the Army can leverage these emerging technologies to better describe, visualize, and direct operations in the information environment. Mr. Young J. Bang, the United States Army's Principal Deputy to the Assistant Secretary of the Army for Logistics and Technology, for Acquisition, Logistics, and Technology, will help direct this discussion. Mr. Bang received a Bachelor of Science in Leadership and Systems Engineering from West Point in 1993. After his time in the Army, Mr. Bang was the Chief Growth Officer at Atlas Research, a partner and Senior Vice President at Booz Allen Hamilton, and a Solution Architect at KPMG Consulting. In 2022, Mr. Bang became the Principal Deputy in the AUSA. Young, the floor is yours.
Awesome. Thanks, Les. Appreciate it. Maria, thank you very much for coordinating this as well. So y'all hopefully had a great panel just now about social media and information and misinformation. I'm going to stop yapping because y'all came to see the real experts here. And we're going to have a really good discussion talk about data in the information advantage environment. So with that, Stephen and the rest of the panel, if y'all can take about 2 or 3 minutes just to give it a little bit of background about yourselves, and then we'll follow up with some good questions as well as a lot of riffing off of each other, hopefully. All right.
Thank you, sir. Ooh, fancy microphones. Hey, I'm Stephen Riley. I'm a customer engineer with Google, and I work primarily with Department of Defense and Army accounts. I prefer the Army ones, as I spent 22 years in Compos 2 and 3 as an armor officer, and thusly, I'm going to ask you all to please use very small words. Thank you. I have a software engineering background, and in my copious spare time, I teach at Seattle University, computer science. Looking forward to talking to y'all. Thanks.
Hi, my name is Edward Cao from MIT Lincoln Laboratory. As Dennis was, thank you, Dennis, was giving a little bit of a background. I'm actually more of an academic background. I did my PhD thesis in statistics at Harvard with a thesis on how to conduct causal inference on social networks. So when I returned to MIT Lincoln Lab, a lot of my colleagues there were wondering, hey, why don't we try this, in quantifying influence and really understand from the data-centric perspective how the campaigns, especially coming out of our adversaries, and how we may counter message against that, and how do we conduct assessment and awareness. And now I'm really happy to report over the last 6-7 years, we've made a lot of strides at MIT, really developing AI-assisted narrative discovery, but I would say most importantly, really understand the causal influence propagation from our adversaries and understanding the different communities, the target audience, and how our adversaries are reaching them, and also how we possibly can project, put our positions out there as well motivated by the last panel. So really looking forward to learning from you all.
Awesome. So I promise to keep it into 1 or 2 word syllables because I'm not as smart as all the academics here. But if you think about it, the Army's driving a lot of changes with the digital transformation. And as we're looking to really advance in global advantage with information, right? We don't want to have our soldiers have a fair fight with our enemy, right? And there's a lot of efforts going around there around data. And how do we look at data for the advantage from an information advantage? How is your organization doing this today, whether it's for yourselves or for your customers? And then how do you also measure progress against that? So maybe we just start in the middle this time with Mike. Great. Ed?
Yeah, I think I'll just try to hit the main points in the interest of time. In terms of that kind of information advantage, as Mike was saying, definitely I think AI has a strong role. I would just put out my soapbox right now. As we talked about last panel, right? Our adversaries will be using and are already using generative AI. So in the sense we don't have a choice. I mean, I think there's ethical issues about using generative AI to put out content, but in terms of using generative AI at least to automate the understanding of the information landscape is critical. I don't think we really have a choice there. So that I think is very important. But I don't think, at least as an AI scientist, I don't think generative AI will be for the short term usable as a fully automated tool. So I really foresee really a human AI interaction. So how does human work? How does human analysts work interactively with AI to really get at the intelligence that we need is very important. And lastly, I just want to again say, really understanding the flow of influence on the social network is paramount. And I think last panel also said motivated the need to have predictive inference, prediction of where our adversaries are projecting and exerting their influence, but also I would say actually prediction of how well we expect to do in countering that. I think causal inference actually introduces an important aspect, because when we look at the problem through causality, that is naturally a lot more predictive than just correlation analysis.
Lots said there. I'm going to pull the threads on those a little bit later, but I'm going to give Stephen a chance to respond.
At this point, I feel like I'm just going to be grunting at you after that. That was awesome, and I want to read your thesis now. So Google, y'all probably heard of it. We're trying to make it a thing. Our mission is to make the world's information accessible, universally accessible and useful. And our vision is to make the world's information available with a single click. From a data platform perspective, I think I just described what we're looking for in terms of being able to organize the Army's data. It's what we do, and our first metric that we really look at as success is when our name became a verb. So that was pretty big for us. And I don't want to be crass about it, but we're a public company. We have to measure our success in revenue, and our search revenue is frankly disgustingly huge. So we're doing okay. I desperately want to take the approach that Google has taken over the last 25 years and help the Army achieve exactly the same thing, maybe without the universally accessible part. I know we got some, security issues with that, but we can do it. There is nothing except the misinformation problem. That's a little harder. There's nothing that we want to do with Army information that the commercial world hasn't already done. So please let us help you. Please. I want our Army to be better. That's all I want.
All right. So I told y'all I'm not going to go with those canned questions. So we're going to start riffing on some of the things that you talked about. A couple of you guys talked about a lot of things, right? So I really am chomping at the bit to get to Ed to talk about causal inference, right? Data, we don't have a statistics background like y'all, but we know there's a correlation between data and patterns and insights, right? But there's a huge leap to get to the causal portion. So I'm curious how you look at that and how you are actually addressing that.
Thank you, sir. You say you don't have statistics background, but you asked just you hit the nail right on the head. So I bet. Thank you. So thank you. That's a great question. I think instead of at the risk of throwing around math terms, which I think is not going to be very effective, I would just use a concrete example. So one of the results that we recently obtained over the last couple of years is doing analysis on the infamous Russian disinformation claiming U.S. biolabs, especially in Ukraine, and in fact Putin used that as a justification to invade. And so when we analyze that data on Twitter, by just building the narrative content and the social network around that, we can see sort of these three communities, right? One community representing the source of Russian propaganda, right? They're really entrenched. I don't think we're going to change their hearts and minds, right? But there's also sadly to say, a much weaker debunking community that's pushing against that. Much weaker, much smaller. But perhaps the most interesting is we see an audience community. Now, this is where the battleground is, right? Between the Russian propaganda and the debunking community, more like anti-Russia, pro-US. They are competing for the hearts and minds of the audience community. So when we apply causal inference, we're literally asking the question, can we quantify what difference it will make in the information landscape without a particular actor or without a particular influence pathway? How would that messaging, both from the the propaganda side and also from the debunking side, how would that change in terms of flow to the audience community? Because that's what really matters. And when we apply, again, causality, we're able to find not only the key influencers, but the key influence pathways into the audience. And our most recent result is we're able to even use that to do predictive inference of who will be the most effective messenger from both sides, on the source side as well as the audience side. And that's getting closer to actionable intelligence, because that informs you who should speak your message and who you should interact with. And we, as I said earlier, right? And then we can do prediction based on that. So that's, in a way, we produce concrete results that's much better than correlation metrics like retweet count, page rank centrality, right? Like likes, number of tweets. So those are correlation that does not indicate actual influence, but we're advocating for causality.
So, Mike, I know you're chomping the bit, and I'll let you get to it. So what I heard you say, so I was actually looking from a statistical to leap into more of a cause effect context of like social or relationship or scientific, but you addressed it really well. You really looked at kind of the information and the vector and the directionality and kind of backward tracing uses. I'm assuming kind of a knowledge graph to look at that. And I think that makes absolute sense. And it probably really applies to us in the Intel community here, right? And looking at that. Now, Mike, just to shift to you, since y'all have a good background on CAI and PAI, I would love to get your take on it. And then are there things that y'all are doing to look at misinformation, causality in that same context? And are there ways to filter and sort those things out? And how are you looking at that? So, Stephen, slight shift for you since you kind of teed it up, and you could bring that back in, but you teed it up about the accessibility and availability of data. And arguably, I love that you use the term that Google is now a verb, because I use it all the time. Like, hey, Google it, right? But when you think about, when y'all first really came into the search engine, you did the searches just like all the other search engines, and you typed in a question 7 times, and it really still didn't give you a good response. Although y'all started then, right, creating your own secret sauce, your algorithm, right? These days is really the Gen AI of how you actually get it the answer better. And so the searches are much better, obviously, in Google Break. And those are very good transitional and evolutional type of things. But how do we revolutionize that for the military and the military construct? Because look, you talked about accessibility and availability of data. I say there's too much damn data out there. And we can't overload our warfighters and our leaders with too much data. You talk about analysis paralysis. We're going to have data overload and analysis paralysis. We can't make decisions. We can't let that happen to our leaders, right? So understand how you guys did search and evolve to Gen AI. Break, that's great. But again, how do we revolutionize it for the Army, for our leaders? Don't give them too much crap of data, but give them the insights that they need to really make their decisions.
Okay. I want to start with LLMs. Don't do it. 90% of the time, don't do it. It's the easy button, I know, but using LLMs like ChatGPT, Gemini, marketing is going to be irritated that I said ChatGPT first. That is boiling the ocean to make yourself a cup of coffee. You don't have the compute resources to run effective LLMs down at the tactical edge. And in DDIL environments, you need to be, really careful how much compute you try to push forward, vice how much you keep back in the rear for horsepower. So I set that up because Google was improving the search results, the quality of the search results, long before LLMs ever came into being. So how did we do that? We did it a couple ways. One was by watching which search results were clicked on most often. It's just a simple matter of watching and saying which of these things was most useful to the most people. So statistical model there, right? The second thing was we started building a knowledge graph. We've got a gigantic knowledge graph now that represents, we'll just loosely say, commonly accepted truths, commonly accepted cause and effect relationships. How we built that, that's part of the secret sauce. Can't talk about that, but we ground the search results in that knowledge graph. So now we've got two things working in tandem. We've got what's been most useful to the most people, and we've got what is actually a good result because it conforms with generally accepted truth. All of this doesn't require LLMs. All this requires a heck of a lot horsepower than LLMs. So how do we do this with the Army? Well, I just described it. Let's start building a knowledge graph of things that are true for the Army. We don't need to train a gigantic LLM with all of the ADPs and FMs and everything and say, all right, we've got a model. You could actually encode all of those ADPs, all the operations stuff, all the intel stuff. We could encode that into a knowledge graph, which requires, I'll just be hyperbolic, infinitely less compute power. That's something you could deploy forward on a pretty small box. So I encourage everybody to look first at the old ways of doing things. They tend to be more efficient. Yeah, you got to think a little harder about how to implement them. But it's a lot more efficient and it's very doable.
So there's a couple things I want to unpack with you there, but you know, I really resonate with LLMs and your comment there, right? Because everyone throws everything at LLMs. Look, LLMs are great for general purpose, right? And if we could mine the context out of that, I think actually using that in combination, right, a hybrid approach with SLMs, right? So context from general purpose LLMs, SLMs for specific military terms, jargon, cyber terms, whatever have you, to get better fidelity in the results. And then, like you said, do you really need LLMs and SLMs at the edge? No, right? And if you use that and overlay kind of a knowledge graph to get at what you were talking about, I think that's a much better practical implementation of things, because you're right. We can't afford all the compute and resources that we're going to need to process all that, or really do the training on it, or even the retraining or the inference at the edge, right? So I love that comment. I do, though, want to unpack about the commonly, I forgot what you said, the commonly accepted truth.
Commonly accepted truth. Yeah, I don't know how else to describe it. That's not a technical term. It's not a term of art. It's how I describe it.
So tying y'all back into it, right? And again, I promise I'm not a statistician, but if I was our enemies and our threat, I would actually just overload existing data sets with misinformation, and statistically, that commonly accepted truth now shifts. And so how do we look at that? How do y'all look at that? How should the Army be thinking about that? Yeah, well, let's start with you, Stephen, since you actually just left off with that.
I know you're kind of like talking about shifting the Overton window of your knowledge graph. Google does not blindly add information to the knowledge graph just based on what we index out there in the world. Yes, you could theoretically overload it and start shifting truth on a given axis to some degree. But, you know, as we index stuff, the data that we index is also run through the current knowledge graph. So it's kind of about to get technical, backpropagation training of a neural network. Things just changed a little bit each time. But we also have humans in the loop. We are watching what's going on with the trends, with the shifting of the, we'll say the Overton window there. We're watching it. And that's an important thing that we need to remember. We cannot abdicate human reasoning to the machines. We've got to have a human in the loop at all times, especially with those LLMs. LLMs are dangerous because they look like they know what's going on. And then you got the hallucinations. Yay. Oh, I lost the thread there. Oh yeah. So yes, we have a human in the loop watching how these things are moving and making sure we're not shifting too far in one direction on a given axis, which of course introduces bias. Google is biased. Everybody's biased. And so you got to look out for that too. Who is the one that's the gatekeeper of the shifting of the Overton window? Whose values are you implicitly encoding in the data set that you're now using? Rather famously, Google's a pretty DEI focused company. I don't think that's any kind of secret. And you saw our image generation stuff that produced a picture of the founding fathers in every race, color, and creed on the planet. It was a reflection of our values. It ain't the truth. So we got to be really, really careful with how we build our biases into these things.
Hey, Ed, I'm gonna jump to you since you were chomping a bit and your statistics background there.
Yeah. So thank you, Stephen. I really echo of what you said. I definitely like piping all the data through the generative model is just not practical, not feasible. Before I answer that question, basically, really, I think what we've been developing at MIT Lincoln Lab is really targeted collection, but also targeted, prioritized processing, right? So like I said earlier about causal influence, so you want to prioritize the most influential content that's being spreading, for example. Now, going back to, sir, your question, about, well, what about unreliable content, right? So again, I think this is where understanding the information landscape is very important. Like going back to the biolabs, right, example I gave, right? So I think it's very important to segment the information content by where it came from, right? So I think you would expect, right, information content from the propaganda source community to reflect that particular biased belief, as Stephen was saying, right? And I'll give you another example. Like last year, we've been doing a lot of collection and analysis on Telegram on the Wagner narratives, right? And so as we were doing that, lo and behold, we discovered through human AI teaming that there was a whole narrative about Prigozhin being alive in Mali, after the assassination, right? We're like, this can't be true, but and then we look at, well, where did that content actually come from, right? And then lo and behold, they were from mostly Wagner channels and local Mali journal outlets, that kind of thing. So, and when we realized that content didn't actually propagate to the mainstream Wagner nor Russian journalists, that's indication that, hey, that content is probably not that reliable. So I think really, for me, I think the key solution to that problem is, again, really having an understanding of the overall information landscape.
Hey, so I'm just gonna throw a softball up to you, Mike. So building on what they both said, right? Y'all have Dataminr, y'all have access to a lot of that, and clearly you can do a lot of things with it and filter things. But are you guys thinking from a product roadmap perspective, kind of like what Ed was talking about, segmenting content and potentially throwing a quote reliability score? So I always a big fan of Texas Hold'em, right? And you see on there on the flop, 50% chance of win. Oh, and the river, right? Those type of thing. It'd be interesting from a product perspective if y'all are thinking about evolving into that way. So we can tie it back to what I said for our leaders. We can, but it takes a lot of time to give us all the information. It'd be easier if we had some type of insights with some type of reliability scores for our warfighters and leaders to make decisions. So kind of thoughts. So, let's talk about poison data sets, because y'all know we have a hashtag defend AI, right? A layered defense framework for algorithms, right? So we could adopt it. But one of the basic table stakes things that I talk about is poison data sets. And so if you look at all the, say when, I don't want to say ChatGPT, but okay.
Do it.
GPT-3, how's that? Or 4. Everyone says, it's trained on the world's data. I'm like, no, it's not. It was trained on what? 8 to 10 large data sets that are out there, which reflects a lot of that. But a lot of times the data sets can be distributed. So you don't actually have to poison the whole data set. You can get into a server, right? From a distributed architecture perspective, that's tied into everything else and poison a very small piece of a server to poison that data set to go into your training data set. And so I'd love to kind of get your thoughts about the basics of that type of stuff, right? And then we can get more advanced if you'd like.
Can I claim first?
Absolutely.
Everybody who's acquiring AI stuff from the commercial world demand to see where the data came from. Google ain't going to tell you. Demand it of us anyway. Microsoft ain't going to tell you. Demand it anyway. We have already seen cases where companies building large LLMs have sourced data from other companies that say they have a bunch of data, and it turns out they source from other companies that are giving some pretty bad stuff. Maybe not deliberate misinformation, but stuff that absolutely would not comply with our nation or Army values. Okay, demand it. And don't tell Google Marketing that I said that. This is why I like knowledge graphs better than LLMs. You can train an LLM, but how the heck do you find out what data went in there? Like this one floating point number in the middle of the gazillions in there. How do you know what that encodes? You don't. A knowledge graph, you can surgically alter it as you need to based on the things you see. Like, oh, we got a poison data set. There is this relationship between these two things that absolutely should not be there. Yoink. You can delete it surgically. In other words, you have explainable AI when you're using a knowledge graph. LLMs are very, very useful. They are, for a few cases, they're what you got. They're going to give you better results. So yeah, I know we got to use them sometimes. But in all cases, demand to see where that data came from and don't stop until they tell you. And don't tell Google I said that.
So Stephen, you'd be a huge fan of what I've been pushing about a data bomb.
Yes. Yes. We've talked about this. The data bill of materials. Famously, after SolarWinds, people are asking for a software bill of materials. What software components went in? We must develop some kind of data bill of materials, which term I got from you, sir, and make that a standard part of acquisition of these AI systems. We've got to do it because we're already seeing this problem, whether you know it or not.
I love this. Not practiced at all. I should pay you $10, right? This is not a plant, right? This is what you get when you riff. I'd love to kind of get your guys' thoughts here too.
Sure, I'll take a whack. I again pretty much agree, but I would throw in another potential solution to that. So earlier I talked about human AI teaming, so I'll provide a little bit more detail. So something that so we have been developing at Lincoln Lab is basically using the foundation model to encode, right, to represent the information in the semantic space. Again, let me repeat, the semantic space. And I think that has been basically the AI revolution, right? Gone are the days of binary keyword search, right? We're in the era of allowing human to have direct access to query and retrieve information by semantic content without actually knowing the specifics of what you're looking for. I'll give you an example, right? Like going back to the, right, when we're monitoring Wagner or the Ukrainian conflict, right? If I input like a semantic prompt, like, Ukrainian casualty, civilian casualty, which is a very common Russian claim, on the Ukrainian forces, right? And lo and behold, various narrative content will come up, right? Some is talking about the HIMARS, some is talking about, specific buildings, some are accusation of Ukrainians being Nazis, but they'll come up. My point is, we're in the era of semantic search where you don't actually need to know exactly what you're looking for, and that's very powerful. And because of that, I do believe that's a very powerful way to separate out actual information as useful from the poisonous information. Again, I think the solution I'm promoting is human AI interaction through semantic prompts.
Hey, so let's just knock this one. This is a real quick one. It'll be short answers. So Steve, over what period of time did you develop your knowledge graph using what inputs?
Okay, I've been at Google for a little over 2 years. I was not there on day one. Otherwise, I would not be sitting here and I'd be enjoying my private island out in the Pacific. We've been, let's see, first stage was just indexing the internet. And it was just raw keyword search, did a little stemming on the words you're searching for, but that was as close to semantic as we got. Then we started adding more sophisticated natural language processing on the query to be able to search different flavors of the question you wanted and put those results together. None of this is anything Google invented, by the way. We just built it at scale. But this was all previous research. Then later on, as we discovered there was too much information, it was absolutely overloading. We could not figure out how to get the best results to people because, frankly, that whole watching people click and gathering statistics was too flat. There was no statistical relevance to any of it as the information kept going. So that's when we started building the knowledge graph on the things to be able to get better semantic search. Different approach than what you were talking about, sir. But that was our way before we could scale really sophisticated AI stuff. And then how did we build it? Just the stuff we were cataloging and built a network that way, and then started iterating on the thing before we incorporated the knowledge graph into the search. So you got to build the thing, you got to test it, you got to refine it, then you can start using it. But it took years and years and years before the knowledge graph was incorporated into search. So it's a big task, not saying it ain't. But yeah, it was in response to us not being able to give you good search results.
Hey, I realize the level of discussion here is maybe a little more technical than people might have expected. So let me bring it back a little bit more, back to our warfighters here. There's a lot of efforts going on across the Army around data and being data-centric, right? And we already talked about just a S-ton, that's a technical term, of data, right, that our soldiers have access to. But when we think about it, you just talked about how difficult it was with all the data out there. We have so many systems that are, with data that replicates data, right? All of those, the data wrangling problem, right? So how do we help our warfighters, right? And how do we help the lower echelons? They don't have a data engineering background. They don't have, you talked a little bit about citizenship, right? We talk about citizen soldiers or citizen data scientists, and we want to give them basic tools to do that. But how do you guys look at helping our soldiers with that data wrangling problem if they don't have a data engineering background?
I'll take a whack at that. So we, the capability I was sharing with you earlier, right? So we're just at a stage of pursuing like technology transfer, to various organizations. And I think what we have found so far is absolutely critical to start with a proof of concept, directly with the day-to-day analysts and really observe how they would use this kind of technology, starting from, well, what exactly is the task? What exactly is the requirement? And really going through that human-centered design process and to match the data-centric, right, tool set to the day-to-day operation. And really iterate on that, I think, at a very early stage before you even invest, huge amount of budget into building out the software, the human interface. But we have to start early. What exactly is the use case? What exactly is the workflow? What exactly is the timeline? And build the technology, the data science, the evidence, the user interface, everything around that from very early stage.
I've talked a lot about indexing, that being what Google search really does. It just indexes everything in the internet. But what we haven't talked about is filtering. How do you narrow down the kind of stuff that you're getting, that flood of information? We have used AI, ML, really ML stuff for the last decade. I'll give you an example. YouTube gets over 500 hours of content uploaded to it every minute. Humans can't keep up with that. We can't keep up. And so we developed models to recognize things that we don't want, kids to see or even adults to see. It's multimodal. It works on video, imagery, and the sound behind it. To scan it and do over a 99% accurate assessment of whether something should be allowed to be seen publicly, should be allowed to see only the adults, or shouldn't be allowed to be seen. That kind of thing we could develop too, based on the domains that Mike was talking about at the different echelons, at the different grades, different kind of models to be able to filter all this massive information for the particular role that that soldier has.
All right, Stephen, going back to you, based on what you just said, and also a question. You talked about all the content, video, for example, that we can't keep up. I used to joke 10 years ago, like, hey, pretty soon algorithms are all they're going to do is just watch videos. But to your point, there's so much content and data that's out there. And going back to this question here, and it could be around imagery, it could be around video, it could be around text. But the context is that around misinformation again. One of the abundant misinformation methods for Israel-Hamas conflict is recycling of old images from Syria. Recycling old images for current events are common. How are you managing this? And is that a responsibility for the tech companies to filter or not? Right? We have things about, watermarking generated AI imagery or those type of things. But how do you guys look at that? And what is your role in that?
Okay, let's start with that second part. What's Google's role in that? What's the commercial company's role in that? Please ask Congress. They have an opinion. The companies have an opinion. The government has an opinion. We haven't worked that out as a nation yet, where that line is. And I would really be nuked by Google marketing if I expressed an opinion on that. So I'm not going to. But we're still working it out. We're still working it out. And it's something that we collectively need to work on. Let's go back to then the first part. At Google, our approach is to turn everything into structured data. What I mean by that is take an image and somehow reduce it down to a row in a database table, or a little blob of JSON or XML, whatever your structured data flavor of the week is. We figure if we can convert everything to a set of data that a machine can read, then a human can also read it because we can present it in a nice way. But then other machine systems can read it to be able to do the filtering, the scanning, the, like, hey, no, we're not letting kids see this. And so what we've done over time is we did this early on, like everything was API driven, convert everything to machine readable. And then we figure we can enhance our systems and grow our systems as we go. But the first step is converting it to structured data. And Google has an awful lot of products that can help you with that. Just talk to me after.
Hey, I feel like I got to do at least one more from the audience here before we go back to your human AI teaming, or that's what we call it. But question here says, how does panel see the potential capability of quantum computing to hide the source of data from adversaries, as well as the reliability of information within a scope of time?
How many days?
So that was a softball. So, Ed, why don't you start with that?
Sorry, you mean quantum computing?
Yeah. So you want me to read it again?
Sure.
Because it was a lot.
Yeah.
How does the panel see the potential capability of quantum computing to hide the source of data from adversaries, as well as the reliability of information within the scope of time?
Yeah, so I just right off the bat, I admit that's not my expertise. Okay, but we do work on quantum at Lincoln Lab, and I've seen a few talks. So we collaborate with the campus, MIT, on quantum stuff, and we're probably a ways off. I don't think if you really care about like the next generation of compute, I recommend that probably it's before quantum could come to realization, probably something called a superconducting computers. That's probably gonna come first, and that's gonna speed up what we have by at least 100 times. So probably in terms of a timetable, that's what personally I believe superconducting computers before quantum. Thank you.
That's when we estimate at Google that we're going to have a functional quantum computer powerful enough to break today's PKI, 2045. So not something we need to worry about right now. But yeah, happy to talk about that outside later. That's just opened a huge can of worms with that question.
So like Ed, I'm not a quantum expert, but I'm going to give you my 2 cents. All right. You guys don't think that's funny. All right. So
I was waiting. Like,
really, I mean, so the question is interesting because it talks about the hiding the source of data, right? And so like, if you think about quantum, it's really it's like everything. Certain things should be thrown on GPUs. Certain things should be thrown on CPUs. Certain things should be thrown on quantum computing and other things on quantum annealing. So from my perspective, I don't know that hiding data from adversaries or finding the data from adversaries is a appropriate question for the quantum computing. Right? If you think about it, it's really about certain mathematical equations that are incredibly hard to crack at this point to answer that. And so unless you're thinking about how you're getting at deep fakes, and even on that, again, same thing, you got to figure out the math problem you're trying to solve here. I don't know that that's a good application for quantum computing versus some of the other things that we got going on now. Okay. Now let's go back to your human AI interactions. I think that's a really good one. We have efforts across DoD. I think y'all know that the DoD is the only organization out there that said, hey, you got to have human in the loop or human on the loop, which I think is awesome and commendable. But I would really like to get your perspectives on that, right? So obviously, skip the self-supervised learning, that type of stuff. Okay. But really, how are y'all looking at things in the future, whether it's 2030, 2045, whatever? How and at what point, as we get towards AGI and singularity, what do you view the role of the human and the AI and their interactions are now and what it needs to be in the future?
Keep the human in the loop, always, always, always for national security. Boom.
I'll just add to that by saying, I think what human analyst offers is far more than just sort of confirming whether content is, it gives approval to the content. But I think human analyst actually provides the coloring and the context and the mission interpretation, right? That I just don't think we can expect, machine to be able to do that. I think the machine is really good at aggregating information. So when the human applies that interpretation, you're doing it at a mass scale, right? It's to scale up that interpretation, but not actually making that interpretation. So I would advocate always going to human analysts to provide that. Well, how would you name that narrative? How would you put that narrative? Since we're talking about information environment, how would you put that narrative in the context of the mission of the overall information landscape? And I do think that's also an important way for that analysis to be impactful across different services and not just for that particular unit.
Hey, so one more question before we go to kind of closings. So it's not directed or accusatory to either of y'all. But I'd be curious to kind of get your thoughts in general, right? There's some perception about tech companies being anti-American and unpatriotic. We know kind of separate. But let me also add to that. A lot of times on the government side, for all obvious reasons, to include cyber and risk perspective, we wanted better insights into data or into the algorithms or into the hyperparameters or whatever. And a lot of times the tech industry, not necessarily y'all, are like, hey, no, that's our secret sauce and proprietary information. But in the same breath, they turn around and give it to China because that's part of doing business in China. And so I'd love to get your perspective. I know some of y'all on the panel have a stance about not actually doing work in certain countries, which is great, but I'd love to get your thoughts about that as it relates to your company as well as just kind of tech sector in general with that specific example.
Google's history in other countries is a matter of public record at this point. I'm not going to belabor that. Yeah, we've had a complicated history, but here's the bottom line. Corporations measure success in dollars of revenue. National security measures success in American lives not lost. We have to figure out a way to merge those. We have to figure out a way to get those two continua of success measurement compatible with each other. And if we can't find a way to do that permanently, then on a case-by-case basis, as you acquire new systems from the commercial sector, we've got to figure out a way to balance that. We report to our shareholders. Y'all report to the president. We need to figure out how to make those compatible.
I guess from Lincoln Lab, we'd love to figure out a way to work with you guys, with the private industry. Like, I think the recorded future here too, love to have conversation. Yeah.
Yeah, so I won't delve into more of that since there's also press here, but I really wanted to thank y'all. Oh, my bad.
Yeah, as I said from the beginning, I really champion considering causality and really quantifying influence to really map out the information landscape and really keeping in mind the different population that's competing, the different population that's being targeted, really looking and mapping out the influence pathways and channels through all those.
I'm going to put my professor hat on for a sec and give you all a homework assignment, respectfully. Please, if you haven't read it, look up Captain, I think it's pronounced Suchik's article on Modern Warfare Institute called 3 Wicked Problems. I think the full title is like 3 Wicked Problems Preventing the Army from Becoming a Data-Centric Organization. But please read that. It is excellent. And I think it demonstrates what this next generation of officers is capable of in this arena. Second, ADP 3-13 information, figure 1.1. It's the cognitive hierarchy. I'm sure some of you have seen it. Now I want you to go look for the data science hierarchy of needs and compare those two pyramids. It's going to show you exactly what we need to do as an Army to be able to assimilate all this information and turn it into knowledge and wisdom. And finally, this isn't the homework part. The Army has been a data-centric organization since the day some caveman counted how many of his buddies there were and changed his tactics based on that number. We have always been a data-centric organization. It's one of the reasons we're, the best Army ever. We just need to keep doing it and keep getting better with it. Please don't let this problem scare you. It is tractable. We've already solved it in the commercial world. We just need to get better at it. So please don't be intimidated by this. In fact, be energized by this problem because it's going to be great when we solve it. It's going to be great.
Awesome. Thank you. I know we're getting the yank, but I appreciate everyone's time. I think there's networking. I think y'all should approach the panel about questions because I know there was a lot of questions that y'all had. So thank you very much.
Thanks so much. He's doing the selfie there, Doctor. So he can put it on Google.
There you go. Yeah. I got to convince my boss that this was worth it.
It was worth it. We appreciate it. So, let's give these guys another round of applause, even though they were over time just for a little bit. Since you've been such a great crowd, we have some gifts for you outside. This is a free book if you want to pick it up. It talks about what we're trying to solve. The name of it is called Venture Meets Mission, Aligning People, Purpose, and Profit to Innovate and Transform Society. And it talks about solving this problem. I'm on page 117, by the way. That's why you got a copy of it. All right. Enjoy your lunch. We'll reconvene back at 1 o'clock.